My project is about exploring object detection in an image with a pre-trained convolutional neural network classifier. The motivation is from 2802 intelligent systems. I've learned how to build a neural network model from scratch to classify handwriting images, um, and they have worked quite well. So far in 2812, we have gone through how to use convolutional operations to convolve an image with filters to extract certain features for a lot of applications, such as image sharpening, edge detection, corner detection. So naturally, I want to explore how to combine all of these ideas and intuitions together to use convolutional neural network for image classification and object detection. Uh, there's two parts to my technical approach, using understanding how CNN architecture works and how they are used for image classification. And will be also using familiar object detection techniques we have learned so far, which is image pyramid, sliding window, and non-maximum suppression. CNN architecture and image classification, we can see a simple diagram of how CNN works. Oh, this is a VGG16 CNN network by Google. In this project, I'm going to use ResNet 50 because it works a lot better than VG16 and is pre-trained, loaded with all the weights that have been trained on about 1 million images on ImageNet database. So the basic methods, the basic steps are generate a multi-scale image pyramid using sliding window to extract interesting areas in the image, pass it through a pre-trained image classifier, in this case a CNN ResNet 50, use non-maximum suppression for the bounding boxes, then output a bounding box on the recognized object and what type of object it is. So these are the familiar object detection techniques we have learned. For the implementation, these are the hyperparameters that I need to sort of adjust and figure out what to do for the algorithm to work best on an image. So we have pyramid scale factor, window stepping size, region of interest size, minimum confidence, and CNN input size. The results, it works quite well sometimes, and it doesn't work on other images basically. So we can see here in the bare image, it's sort of filtered out and got two bounding boxes on the bare, and after non-maxima suppression, we end up with only one. Same here for the beer class as well, but we can see in the vacuum, it has the final two bounding boxes on the vacuum. And in a real world situation, probably the lighting was a bit dim. It sort of picked out the notebook, but didn't do very well on the mouse or the iPad behind it. Improvements, we probably could use a different classifier and also introduce heuristics to picking the region of interest and other approaches that could perform faster. We've got RCNN, which is region CNN, and the new state of the art, which is YOLO, you only look once algorithm. Concluding remarks, even though I pre-trained CNN basic techniques and computer vision were utilized in this project, it has allowed me to dive deeper into understanding of what deep learning convolution neural networks entail. For the coding part, let's see. I have, this is only imports. These are the two helper functions, sliding window and image pyramid. The main algorithm is here. I have loaded ResNet 50, the CNN network, with all the weights that have been trained on ImageNet database. These are the hyperparameters, and I have picked the beer class image. I'm going to run the default parameters, load the image, check the height after resizing the image, and this is the main algorithm. So it found 224 region of interest, performing prediction, feeding it through the CNN. It's gonna take a little bit to run. This is just and there you go. These are there's only one label, and these are all the bounding boxes found with a very high probabilities. And also you would know only one object detected. Now I'm going to perform non-maximum suppression, and finally the result. And we can see here before non-maximum suppression, these are all the bounding boxes with a very high probability of a beer glass. But after performing non-maximum suppression, we end up with 2 bounding boxes, which is pretty good. And that's it for now.